Talking about the parabola as our fourth and final conic section. A parabola is the set of all points in a plane that are equidistant from a fixed point, which is the focus, and a line, which is the directrix, as you see kind of traced in here. So a couple additional stats to go along with the traditional parabola we're used to. The equations could look in either of these two forms. C is an important term that is going to refer to the distance from a vertex and a focus, which we'll talk more about shortly. C also relates to something called the focal chord. The focal chord is always parallel to the directrix, as you can see bolded in here. The focal chord is a line segment. The length is 4c. And the directrix down here is a line that goes on infinitely. The focal chord helps us to get the width of our parabola. All right, here are the two formats I referenced before. If your x term is your squared term, it is a vertical parabola, meaning it opens up and down. And something to think about is what we've graphed parabolas as for a very long time now. Y equals x squared is how we're used to graphing parabolas, right? Our parent functions. That was a parabola that opened up or down. This is just a different formatting of that same parabola, with the squared term being x. The second version over here is where our y term is squared. So it's kind of like x equals y squared, which is a little different than we're used to. And that will open left or right. Specifically, the vertical parabola opens up when c is positive and down when c is negative, while the horizontal parabola opens right when c is positive and left when c is negative. And you see those blue dots? Those are the foci that are put inside like the pocket of the parabola. Again, here's a bunch of orientations we can see. So in the top here, we see when our x is our squared term, it's opening up or down. And if it's opening up, they use p as the variable. We're going to reference it as c. The focus is above the parabola if it opens up, and below the parabola if it opens down. Below is when y is squared, opens right, and the focus is to the right. When c is positive, opens left, c is to the left. When c is negative. All right, to our first example. So we're going to sketch a graph of this. It's first helpful to figure out which way this graph is going to face. So because y is my squared term, it is going to open horizontally. It's going to open horizontally, and the vertex is at hk. So the vertex is at 2, -1. Be careful with your binomials. Remember, our x value goes with our x value of the vertex. I should say our h value goes with the x, k goes with the y. All right, now not only horizontal, but I also got to figure out what c is. Now this term in front, we're going off of this format. So that 12 is 4c. So 4c equals 12, which means c equals 3. That is positive, so it is opening horizontally to the right. All right, let's start graphing then. A vertex at 2, -1. There we go. Now it opens horizontally to the right, and c is 3, so I go 3 units to the right, and that will be my focus. Put a little f next to it. My focus is 3 to the right. My directrix is 3 in the opposite direction then. So this will be where my directrix is, but my directrix is not just a point. Eesh. It's a line. That's a really bad line. Let me do that again. There we go. All right, there's my directrix. I have my focus. I'm going to list my focus. 5, -1, because I add this c value to the x value of my vertex. Now, the last part is I got to finish off this parabola. And the important part here is referring to the focal chord. The focal chord is 4c units long total. So it's 12 units long in total. And the focus is the midpoint of it. Meaning, if the focus here that I plotted is the midpoint of the focal chord, I'm going to go half of the focal chord length up and half of the focal chord length down. So 6 units up, 6 units down. And I now have I'll connect this to form my focal chord. This is not actually a part of the graph you need to plot, but the points you need, because that tells us the width of our parabola. And you make a nice smooth curve from there. That's our first parabola. And I should list also the directrix is at x equals -1 here. It's a line, so it's x equals -1. All right, let's do another. We're going to graph this parabola, but obviously we are not in our nice graphing form that we just referenced, so we have to first put it in that graphing form. And this will require some completing the square to make a squared binomial. I see my x term is my squared term, and there's another x there. So I'm going to complete the square with my x values and pull everything else to the right side. To do that, I first factor 2 out. Leave a blank there to complete the square. I'm subtracting 8y over and 6 over. Great. Now I need that magic number. That magic number here is going to be 6 divided by 2 squared, which is 9. So I need to add 9 in there. And I need to balance the equation. Be careful. You are not going to add 9 to the right side. You are going to add, you're really adding, by adding 9 there, you're adding 2 times 9 if you were to think about distributing that through. So instead, I'm going to add 18 to the right side. All right, let's work with this now. So we have a 2 in front, still stays there. This factors in x plus 3, quantity squared, equals -8y. Combining those like terms is going to be plus 12. Cool. All right, let's keep going. We're not quite in that form just yet because I know on the right side of my equation, I'm going into this form, I need to have something factored out to have an accurate k value to go in my y. So what I'm going to factor out is -8. I'll leave the 2 in front here, and you can vary exactly the process how you do it, but factoring -8 out would get me y, then let's see, I'm factoring a -8 out of positive 12, so that's basically 12 divided by -8, it's going to be minus 1.5, or 3/2. Now I want to get rid of this here, this 2 in front, so what I'm going to do is divide both sides by 2. I could have chose to divide by 2 one step earlier. That would get me to the same result. That is fine. It's going to cancel that there. Leave me with my final graphing form. There we go. Graphing form. All right. Now I'm going to graph it. So let's see. This is a vertical parabola. It's going to be opening down. So that means the vertex will be at -3, 1.5. And I'll plot it. My C value, since 4C equals -4 in this case, C is -1, which means it's going to open down, which means my focus is 1 below the vertex. Put a little F next to that, my green focus. And my directrix is 1 above the vertex. So it's pretty tight, this one here. And we're going to draw that directrix in. Got my directrix. I got my vertex. I got my focus. I just have to end with my focal chord. Focal chord is the absolute value of 4C units long. So my focal chord is 4 units long total, meaning 2 to the left, 2 to the right of my focus. I'll connect them to demonstrate what that segment is, and I can finish my graph. Ooh, that was not great. Better. All right, let's see. Have I listed everything? I found the vertex. The focus I will list as -3, 0.5, or 1/2. And just for good measure, I'll name the directrix. That's going to be at y equals 2.5. There we go. We have our graph. Length of the focal chord, directrix, focus, and vertex. Let's continue. All right, these next two examples, we're just going the opposite way. Finding the equation from information or from a graph. So what is the equation of this parabola? First thing I want to identify is its orientation. I see it opening vertically. Specifically, it's opening down. All right, so that means it's this form. My x is going to be my squared term. Now I got to find the vertex. Vertex is at the point that looks like 3, -4. Okay, I've got enough to at least get this equation going now. My x is my squared term, so x minus 3, the quantity squared, equals 4c. I'll leave blank for just right this second, because I know the rest of it. Now I got to talk about what 4c would be. And to know 4c, this is my focus down here. We know the focus is c units away from the vertex. 1, 2, 3, 4. It's 5 units below the vertex here, which means c equals, oh, not -4, -5. And 4c then would be -4 times 5, or 4 times -5, I should say, -20. There we go. All right, one more. Find the equation of the parabola with that focus and that directrix. Helpful to graph it to start. And label. That's our focus, okay? Our directrix is at x equals -1. Great. So I already have a good idea of what this is going to look like, right? It's not going to open vertically. That's opening horizontally, because my parabola is never going to cross the directrix. It's going to open to the right specifically. And let's see, can I find my vertex? My vertex has to be right in between these two, the focus and the directrix. So the point right in between the focus and directrix, or really specifically I'm looking to point the x value in between 3 and -1. That vertex will be at, I count 1, -2. That makes sense. All right, so let's start drawing this. My y is my squared term, so it's going to be y plus 2, quantity squared, equals 4c. I'll leave blank for now again. Now to find c, I have to figure out how far my vertex is from the focus. And I can simply count that as 2. So great. So that means c equals 2 and 4c equals 8. And 8 is the number that goes there. Done. We are going to finish off this graph. So again, I'll go green yet again for my focus and focal chord, because my focal chord is 4c units long, so it's 8 units in total. Which means if it's going 8 units in total, it's going half that distance in one direction, half that distance in the other direction. In other words, 4 up and 1, 2, 3, 4 down. There's my focal chord. Finishing my graph. There we go. That is our graph. All right. Here's some practice for you to try out. So I want you to pause the video. I'll show the answer shortly, but go ahead and pause right now. All right, and your answers should look something like this. All right, great job. Keep up the good work.